Alrighty, this is a Tommy Reed. I got the experiment to do on this one. This is a pretty interesting. Let me play it for a little bit and just show you what the guy has.
Hi everyone guys, it's me again, Alexander Grinyov on my channel with another video in which I want to share with you my experience testing different types of coils and their corresponding windings. Guys, today let's say our test subjects will be these kinds of toroids, wound rings. Show you how everything is right now. So look, so I have a toroid here, see? This is a ferrite ring, 120 outer diameter, 120 inner wall thickness. Ferrite ring, 3mm cut, right here, you see? It is solid here. The cut is only in this part. And so my wire is 0.85, approximately 500 turns.
I believe it's 18 gauge on that one.
500 here, 500 here.
500 turns is a lot of turns on each end.
What results
so you're looking at a total of 1,000 turns.
I tried shorting, for example, the end of this winding. With the end of that one, you understand? That is the beginning with the end with the beginning, and so on. And I ended up with this interesting thing. That is, if I connect, for example, the beginning of one winding.
Well, anyhow, you can see the point. The biggest thing that I noticed right away when this thing is actually running
Is the end.
Let me show you, is it doesn't show the amount of power that is going into, let me see if I get this thing run. Here we go. Doesn't show amount of power going into the motor, which is one of the big warning signs I've seen there. I'll put this link up on this particular YouTube. But what I ended up doing is I actually built a test model on this. I'm going to show you where we're at on this. So I ended up building my own version, but I wanted to test everything. And basically what we have here, I have, well, the power supply. I'll explain what I have. I have a RPM gauge here. This is a temperature in Celsius, because I'm curious if this will actually heat up. Now, it's not wind, because I want to see what the load is without this actually being in the stator position and without that. So, and also when this slides in, because there's such a high magnetic field going on in this particular model. I mean, these are N52, so these are very powerful magnets on this one. So let me start this up. I'm going to show you, I got very low power consumption on this. As you can see, we're running not too bad. We're running about 1560, 66 RPMs on this. The temperature right there is, it'll probably cool down a little bit, knowing that it's actually, once this gets in there, it may cool down. But I want to see if there's such a magnetic field that this starts to heat up. Now, there is a slit in the corner where it goes all the way down, as he has on his video. And this is my power consumption. I want to bring it down just a little bit. I like to keep it around 12 volts if I can. It's a little sensitive. So, let's see. Just so we can get it pretty close. This is really sensitive sometimes. So that's pretty good. It gives us at least 170 milliamps we're pulling. 11.8 volts. So what I'm going to do now is actually move this in position. Now, because the magnetic field is so powerful, what I have to do is just move this in. And look at that. It just pulls that baby right in. It does slow down my RPMs. It does change my load a little bit, as you can see. Not much, which is a kind of strange. And as far as the temperature, it's not really doing much. Probably because it's cooling and vice versa. Now, there's no field in this, but the amazing thing is that I'm going to move this away now that we have the RPM, and watch what happens when I move it away, which is, you know, it probably speeds up another 30 RPMs. Not much of a serious load compared to the magnetic load from the magnets pulling the toroid into the center of the rotation of the rotor itself. But it's a very interesting concept. Now, what I'm going to end up doing is actually start wrapping this. Now, I looked at the video very carefully, and of course when he shorts it out, it speeds up, and I think I know exactly why that is actually doing that. Because the windings are opposite half of the toroid, it actually creates like a magnetic back EMF, so it kicks it forward, and that's probably why it's speeding up in that particular video. Other than that, we're not really moving up in temperature. Not too bad. This is pretty sensitive. Just to give you an idea, if I touch it, you'll see how sensitive. I mean, it goes up pretty quick. So I know I'm not actually heating this up due to the magnetic field, but it gives you a pretty good idea of the simplicity behind it. And the cool thing is, I made sure I kept the power as low as possible on this, because you know, power consumption is very good. We're probably less than a little over 2 watts of power consumption on this, which is not bad for this particular motor. And I can actually speed this up at full power. I mean, we're pulling some power now. We're almost at 25, we're over 2,500 RPMs. Now watch what happens when I pull this in. I mean, we're not really even pulling more load, which is amazing. So it gives you a pretty good idea. 25. So why is it actually? It's actually not too bad. I'm going to pull this away and see if it actually starts to get even faster. Yeah, not too bad. So we're at 2,600 RPMs now, and we lost about maybe 20 milliamps under that huge load, which is not too bad. Now, this should be, it doesn't show any real temperature indication. It's actually cooling down, but it gives you a pretty good idea. It's a little noisy. I don't know what it is. It could be those bearings on that, and actually it's also the magnetic field that could be pulling it. But very interesting in concept. So the main thing is, now I want to wrap this. It's 18 gauge. I don't know if I can get 500 turns on each end. That's 1,000 turns. So I will try to do the best I can. Right now it looks promising as far as the load is concerned. But as soon as you wrap this like a transformer, it's going to definitely show. This is why I have a problem with that particular video. It doesn't show the input of the motor speed, which is kind of, you know, red flags to me. So, Tommy Reed, I hope you enjoyed this video.